So chapter 7, we're moving on from logs. We're going to talk about inverse variation. So in the past, you've probably heard of direct variation. So that's when y is equal to a times x, where a is a constant. So direct variation applies when y is increasing, x is also increasing. Now, inverse variation, we have a different formula. So that's y is equal to a divided by x, where a is just our constant of variation. So we have two different formulas, direct variation and inverse variation. So inverse, if y is increasing, x would be decreasing. Inverse kind of means the opposite, so it's like the opposite things are happening. So in example 1, we want to tell whether x and y show direct variation, inverse variation, or neither. So our formula for direct variation is y is equal to a times x, and inverse variation is y is equal to a over x. So we just want to see if our equations match either one of these. If they don't match either one, then it would be neither. So we have to get it to be y equals to see if it matches. So for a, how would I get this to be y equals? Divide x. We want to move that x to the other side. So y is equal to 5 over x. If we're dividing x, which one does that match? Inverse variation. For b, it's already y is equal to. So y is equal to x minus 4. Does this match either one of these? So that would be neither. For c, how would I get it to be y equals? Multiply times 2 on both sides. So y is equal to 2x. What would this one be? Direct variation. It matches our y is equal to a times x. So this would be direct. Let's say we had one that was y is equal to x over 2. There's one like this in the homework. What do you think? Why do you think it's direct? So we want to keep it to be y equals, but what's the same thing as saying x over 2? That would be x times what? 1/2 x, which is direct. So if you're multiplying the x, if x is on top and you're multiplying it, it would be a direct variation. So our a just happens to be a fraction here. But these are the same. You got to know that x divided by 2 is 1/2 x. Well, it could be x divided by 3. That would be 1/3 x. It could be y is equal to 4x over 3. This is the same thing as saying 4 over 3 times x, which would also be direct variation because you're multiplying the x. All right, for number 1, we have the y equals already. It's just in the opposite order, but it doesn't matter. So y is equal to 6x. Would that be direct, inverse, or neither? Direct. Awesome, because our direct is y is equal to a times x. So since that x is being multiplied by a constant, it is direct. For 2, how would I get the y all by itself? Divide by x. So y is equal to negative 0.25 over x. Inverse, because we're dividing by x here. Our inverse formula is y is equal to a over x. So this would be inverse. And then for 3, how do I get the y all by itself? Subtract the x. So y is equal to 10 minus x. What do you think? Neither. Because here we're not multiplying the x, we're not dividing the x, we're subtracting it. So it'd be neither. So example 2 is a little bit different. We have to tell whether x and y show direct variation, inverse variation, or neither. So our formulas for inverse variation we have y is equal to what?
12.
A over x, just as a general formula.
Oh, that's not the formula.
For direct variation, y is equal to a times x. Now here, for the tables, it gets a little bit different because we're trying to find what that constant a is. So in my equation here, if I were to solve for a, get that a all by itself, what would I need to do? Multiply by x. So here I have a is equal to x times y. You can. For direct variation, I want the a all by itself. So how would I solve for a here? Divide by x. So a is equal to y over x. Now we're going to use the constant parts, so these two, to determine if it's going to be inverse or direct variation or neither. So what we're going to do, I'll answer your question in a second. We want to find what x times y is and what y divided by x is. The one that gives us the constant will either be inverse variation or direct variation. So we're looking for which one, if we multiply the two numbers and get a constant, or if we divide the two numbers and get a constant. We're looking for that constant. It's never going to be both. So x times y here is inverse variation. Y divided by x is direct variation. So it's kind of the opposite of what you think, only when you're doing the tables. So only when you're doing the tables, it's the opposite of what you think. Normally, when we divide, it's inverse variation, but here we're actually multiplying the x times y, so it's the opposite for the tables. So let's try to figure out if we have inverse or direct variation. All right, so let's multiply. So we're just multiplying the columns together. So 2 times negative 12 is what? Negative 24. 4 times negative 6. Negative 24. 6 times negative 4. Negative 24. And 8 times negative 3. Negative 24. So if we have a constant, then we have inverse variation here. Because these are all the same number, it would be inverse. So our answer here is inverse. You're not going to have inverse and direct, so you don't even have to do this. If you want to, you can. We can divide. This would be negative 12 over 2, which would be negative 6. Because to figure out if it's direct, we divide. So y divided by x. So negative 6 divided by 4 would be negative 3 over 2. Are these the same number?
No.
No. So it's not direct.
So you would do inverse, and if it's not inverse, then it's going to be direct?
No, because it could be neither.
So if it's not
But
inverse,
if it is
you have to do
inverse,
direct.
you can stop.
Yeah, but if it isn't inverse, then you have to do direct, and if it isn't direct,
Then it's going to be neither. Yeah. So you have to check each one until you figure out. But if it's inverse, you could stop.
Can we use a calculator?
Yeah. All right, let's look at B. So we're going to do the same thing. I'm going to make my little chart here. I need to find what x times y is and what y divided by x is. Be careful because it's y on top.
Oh, it's not going to be inverse.
Let's check.
No, it's
So x times y would be 2. X times y here, 8. Are they the same number? No, so we could stop. It's not going to be inverse. You can cross that one off. Now let's divide. So 2 divided by 1 is 2. 4 divided by 2? 2. 8 divided by 3? 8 over 3. Is this the same? No. So what's our answer? Neither. So if it's not inverse and it's not direct, it would be neither. So let's look at number 4. So I'm going to make my box again. We have x times y. If it is x times y, is that direct or inverse? Inverse. So remember, it's the opposite when you're doing the table. So x times y would be inverse, y divided by x is direct. So let's multiply first. Negative 4 times 20, negative 80. Negative 3 times 15, negative 45. Is it going to be inverse? No, so we could stop there. If you want to, keep making the whole table. But save yourself some time. If it doesn't match up and you know that you did the math right, you could stop. Next, let's divide. So I have 20 divided by negative 4, which is negative 5. 15 divided by negative 3, negative 5. 10 divided by negative 2, 5 divided by negative 1. So what would this be? Direct variation. Perfect. Because it's a constant. So I'm going to make my table again. I have x times y. What else do I have to check for? Y over x. Awesome. So if it's x times y, it's inverse. If it's y divided by x, it would be direct. So 1 times 60 is 60. 2 times 30, 60. 3 times 20, and 4 times 15, 60. So what would our answer be? Inverse. These have inverse variation. You could try dividing too if you wanted to, but since inverse works, then that's going to be your answer. All right, let's look at example 3. So here we have to write an inverse equation. So the variables x and y vary inversely. Inversely means I'm using what formula? Y is equal to what? A over x. Our inverse equation is dividing, even though it's the opposite when we do the tables. So tables are opposite. Then it says, and y is equal to 4 when x is equal to 3. Write an equation that relates x and y. So in the first part of this question, we are writing an equation that relates x and y. So we have to find a. How do you think I could find a? Awesome. I'm going to plug in what's given. So I'm going to plug in y and x. So 4 is equal to a over 3. Multiply 3 on both sides. So what does a equal? 12. Perfect. So we're going to plug that back into our equation. So y is equal to what? 12 over x. That is our equation. That's the answer to the first part of the question. Perfect. Next part of the question says find y when x is equal to negative 2. So y is equal to 12 divided by negative 2. So y is equal to negative 6. Perfect. This would be the second part of the question. So in 6, 7, and 8, we're doing the same thing. It says the variables x and y vary inversely. So which formula am I using? Y is equal to a over x. Use the given values to write an equation relating x and y. Then find y when x is equal to 2. So first thing we want to do is find a to find our general equation. How would I do that?
You would plug in.
Plug in. So I'm going to plug in the x and y that are given. So 5 is equal to a over 4. Multiply by 4. So a is equal to 20. So let's plug that back into our general equation. So y is equal to what? 20 over x. Perfect, because we're just plugging 20 into the a.
20 over 2. Because then we also got to plug in the x.
Right. So this is just our equation because it's asking for two things. It's asking for the equation. And then the second part of this question says to find y when x is equal to 2. So now I'm going to plug in x into 2 into the x.
So y equals 10.
Awesome. So y is equal to 10. Any questions here? All right, let's look at 7. So I'm going to start with my equation. Y is equal to what? A over x, because it varies inversely. So let's plug in our x and y. We have negative 1 is equal to a over 6. So how would I find a? Multiply 6 on both sides. So what does a equal? Negative 6. What do I do with a? Plug it in. So y is equal to negative 6 over x. So this is our equation. That's one answer. Then I plug in 2. So y is equal to negative 6 over 2. Negative 3. Awesome. All right, let's look at 8.
It's pretty simple.
So y is equal to what? A over x. So let's plug in our x and y. So 16 is equal to a over 1/2. Multiply both sides by 1/2, just like we did before. So even though it's a fraction, it looks scary. We're doing the same thing. Multiply both sides by 1/2. What is 1/2 times 16? 8, yeah. So a is 8. What would I do next? Plug it into the formula. So y is equal to 8 over x. Then what do I do? Plug in 2. So y is equal to 8 over 2, which is 4. Example 4. So it says the time t in hours that it takes a group of volunteers to build a playground varies how? Inversely with the number n of volunteers. It takes a group of 10 volunteers 8 hours to build the playground. So you have to make a table showing the time that it would take to build the playground. The number of volunteers is 15, 20, 25, and 30. First thing we want to do is come up with an equation. If it varies inversely, what's my general equation here? Y equals a over x. But here it says that the time varies inversely. So time would be equal to what in terms of t and n? So I'm just replacing time. I'm replacing t into the y. And I would replace, what's my other variable? N, talking about the volunteers, so I'm replacing that into the x. So this is the equation that I'm using. It's the same thing. We're just talking about time and the number of volunteers. So we want to figure out our general equation when it takes a group of 10 volunteers 8 hours to build the playground. Number of volunteers is n. So how would I find a? 8 equals a over 10. Perfect. Because 8 is the number of hours. That's our time. Bless you. And 10 is the number of volunteers. That's our n. So multiply both sides by 10. So a is equal to what? 80. So t is equal to 80 over n. Perfect. So this is the equation that we're using now. So I'm going to write it over here. T is equal to 80 over n. Now it says make a table showing the time that it would take to build the playground when the number of volunteers is 15, 20, 25, and 30. So I'm going to draw my table just like I had the other ones. I'm going to say n and t. These numbers, 15, 20, 25, and 30, is that going to go in the top or on the bottom? Number of volunteers is n, so that would go on top. So I have 15, 20, 25, and 30. Yes. So if n is 15, how do you think I find t when n is 15? Plug it into the formula. Perfect. So here, this would be t is equal to 80 over 15. What's 80 divided by 15? 5.3. We're going to do the same thing but with 20 now. So t is equal to 80 divided by 20. What's 80 divided by 20? 4. Then we have 80 over 25. In your calculator, what's 80 divided by 25? 3.2. And then 80 divided by 30? 2.6. So this would be our chart. This is the answer to the first part. So the second part of this question says, what happens to the time it takes to build the playground as the number of volunteers increases? So look at our chart. The number of volunteers is going up. What happens to the time? It's going down. So the time decreases. So the time decreases as the number of volunteers increases, which makes sense because we said that this varies inversely, which shows one goes up, the other one goes down. In example 4, it takes a group of 10 volunteers 12 hours to build the playground. How long will it take a group of 15 volunteers? So we're not going to make a chart. We're going to come up with our equation first. So T is equal to A over N, the same one that we used last time. Because it says it varies. We're going to say that it varies inversely here. It doesn't specify, but it's the same example as 4. How would I find what A is?
T is 12.
T would be 12, perfect, because that would be the time. How, if it's 12 hours, how many volunteers do we have? 10, so this would be N. How would I find what A is? How do I move the 10? Multiply 10 on both sides. A is equal to 120. So the formula I have is T is equal to what? Over N. Now, once I have the formula, I want to see how long it would take a group of 15 volunteers. So what would I do? So I'm plugging in 15 into the N. So T is equal to 120 over 15. So what does T equal? 8. So it would take 8 hours. Good job, Juan.
See, I know it.